All right, if we think back to Chapter 8, we had a section where we learned a shortcut for specific types of FOILing. So when you were given something like 2x plus 8 squared, you had two options. You could write it all out. You could say that means 2x plus 8 times 2x plus 8 and FOIL it out, which is fine. Or we also said that you could say, okay, the first term is the first term squared. So 2x squared is 4x squared. The last term is the last term squared. 8 squared is 64. And your middle term comes from multiplying the first term, the last term, and then multiplying it by 2. So 2x times 8 is 16x, and 16x times 2 is 32x. And that's how we got that middle term. And some of you chose to use that method, and some of you chose not to, which is perfectly fine. But today we're going to be going backwards. I'm going to be giving you this, and you have to give me the 2x plus 8 squared as your answer. You can go through and multiply the first number, the last number, find the factors, split the middle term up, and that's fine. It's just sometimes they take longer because the numbers a lot of times are bigger. But if we recognize the pattern, it's going to be a lot easier. So we're going to talk about how to recognize the pattern. The first thing we look for is if the first term is a perfect square, which x squared is in this case. Then you look to see if the last term is a perfect square, which it is, 49. So then what you do is you take the square root of each of them. So the square root of x squared is x. The square root of 49 is 7. Multiply them together. 7 times x is 7x. And multiply it by 2. 7x times 2 is 14x. That means that it fits that pattern. Okay, we're double checking to see if this fits the pattern. So if the square root of the first and the square root of the last multiplied together times 2 gives you your middle term, then this fits the pattern. So all you have to do to factor it is take those square roots, x and 7. Technically you're doing this, x and 7, x and 7. This tells you your signs are the same. This tells you that they are both addition. For your final answer, this is the only thing I really need you to get from this, is if you have the exact same thing in both sets of parentheses, you write it one time squared. This is how I want your answer written. You are more than welcome to say, okay, I don't have anything in front of my squared term, so I have my two parentheses, what x and x. What multiplies to give me 49 and adds to give me 14? 7 and 7. Signs are the same. They're both addition. You can go about it exactly how we went about it before. But this one was easy that way. Some of them are going to be a lot larger numbers. So if we could start recognizing perfect squares at the beginning and perfect squares at the end and then double checking to see if it fits this pattern, we can skip some steps in between. So here typically we would have to multiply 9 and 16. And get that big number and try to work it out. Or I can recognize that 9 is a perfect square and 16 is a perfect square. So let's test it and see if it works. The square root of 9x squared is 3x. The square root of 16 is 4. 3x times 4 is 12x. 12x times 2 is 24x. So that's exactly what I wanted. So it fits the pattern. So when that happens, I can write 3x plus 4, or 3x and 4, 3x and 4, exact same thing. Signs are the same. They're both subtraction. So that final answer needs to be written as 3x minus 4 squared. If you don't like to find the shortcut and you don't understand it, that's okay. Just make your chart, do the factors, and then split your middle term just like we've been doing. As long as when you're done, if you end up with the exact same thing in both sets of parentheses, same numbers and same signs, you write it as one thing being squared. Again, 16, 32, and 64. Now this technically has a square at the front and a square at the back, but what I also need you to be looking for are common factors. 16, 32, and 64 are all divisible by 16. So you need to be taking that out. That leaves you with x squared plus 2x plus 4. What's left inside? So you have to make sure it's not factorable. Can anything multiply to give us 4 and add to give us 2? Nothing else is going to work, so that's as far as that one's going to go. So just be on the lookout for all the types of factoring we've done. Taking out a common factor, perfect squares, regular trinomials, all the stuff that we have done this so far. This last section is basically to review all the types of factoring because your test is coming up. This is the last section of the chapter. All right, 9, 12, and 4. 9, 12, and 4 don't have any common factors, but I do notice that 9 and 4 are both perfect squares, so it's might as well check it. The square root of 9y squared is 3y. The square root of 4 is 2. Multiply them together. 3 times 2 is 6. Then times 2 is 12. That is my middle term, so it fits my pattern. So I know it's going to come up with something being squared. So 3y and 2. Signs are the same. They are both subtraction. That's it. It's a lot faster if you can recognize the patterns. If not, you could have done this. You could have said, okay, 9 times 4 is 36. I need things that multiply to give me 36, that add to give me 12. And then you'd find your factors and then split up your middle term, and you still would have ended up with 3y minus 2 and 3y minus 2. And then you would have said, oh, I have the same thing in both sets of parentheses, so I needed to write it as 3y minus 2 squared. 25 through 36 all different types of factoring because it's just kind of looking over everything. So remember to look for common factors. Remember to look for the difference of perfect squares. Remember to see if it's a trinomial, if there's a number in front of your squared term. If there's not, then it's fast. If it is, then it's the 5-step. Multiply the first and the last terms. Good luck.